and NASA detected a mysterious object speeding toward Earth. Some actual bona fide experts think it might not be your typical space rock or maybe any kind of rock or a natural phenomenon at all. It was first detected as a speck of light moving relative to background stars. Leaked NASA Hubble images reveal something impossible. An interstellar comet with its tail pointing toward the Sun instead of away from it. This is only the third visitor from beyond our solar system ever detected. But unlike its predecessors, this cosmic intruder displays multiple anomalies that have left astronomers genuinely alarmed. Racing through our solar system at an unprecedented 130,000 miles per hour, this ancient visitor is doing things no natural comet should. Its path through our planetary neighborhood seems almost calculated, bringing it suspiciously close to Mars, Venus, and Jupiter. And that's just the beginning of the mystery. The comet will conveniently disappear behind the Sun, precisely when it reaches its brightest point, exactly when our telescopes would have the best chance to study it. Coincidence? Or something far more significant? The evidence we're about to show you might change everything you thought you knew about our cosmic neighbors. The leak and the alarm. What NASA hasn't told the public about 3-2 Atlas is now coming to light. Insiders within the agency have quietly circulated unreleased images from both the Hubble Space Telescope and the brand-new Vera Rubin Observatory. These high-resolution observations reveal details so unusual that astronomers worldwide are buzzing with theories and in some cases genuine concern. Let's break down what makes this visitor so bizarre. First, the comet has a dust tail pointing toward the Sun, the exact opposite direction of what physics normally allows. Solar radiation should push dust away from the Sun, not toward it. Second, spectroscopic analysis shows no detectable gas emissions from the comet yet. Normal comets release gases as they warm up, but 3I appears to be shedding only dust. Third, initial measurements suggest this could be enormous, potentially up to 5.6 kilometers across. That would make it by far the largest interstellar object ever detected. Fourth, its trajectory brings it unusually close to Mars, Venus, and Jupiter during a single pass through our system. The statistical odds of this happening randomly are astronomically low. Finally, and perhaps most suspiciously, 3I-ATL will reach its closest point to the Sun while positioned directly behind it from Earth's perspective. This means when the comet is at its brightest and most active, it will be completely hidden from our view. These aren't just scientific curiosities. Several leading astronomers have expressed genuine unease about what these anomalies might mean when considered together. Think about this for a second. A comet blasting dust toward the Sun, no gas we can detect, and a path that takes it by 3 planets in one shot. That's not your everyday space rock. What would you think if you saw these images first before the press releases? Drop your guess in the comments, comet, or something stranger. If you want to follow this developing story as new data comes in, hit subscribe and turn on notifications. This mystery is just beginning to unfold. The path that shouldn't be. Let's take a closer look at 3I-ATLS's journey through our solar system because this is where things get truly strange. After entering from above the planetary plane, this interstellar visitor follows a path that brings it remarkably close to multiple planets in succession. In early October 2025, it will pass within just 30 million kilometers of Mars. Close enough that NASA's rovers might even capture images of it. Later, it swings past Venus at about 0.7 astronomical units. Still remarkably close in cosmic terms. Then, in 2026, it approaches Jupiter's neighborhood, coming within 0.3 to 0.4 astronomical units of the gas giant. This path is so unlikely that it's raised serious questions. Harvard astronomer Avi Lowe and his colleagues have calculated that the odds of an interstellar object randomly passing this close to 3 major planets are extraordinarily small. The statistical probability of such planetary encounters if 3A were on a random inbound trajectory is extremely low, their analysis states. What makes this even more intriguing is how similar this trajectory looks to something NASA itself would design. When planning missions like Voyage's Grand Tour of the Outer Planets, NASA engineers precisely calculate paths that use planetary gravity to slingshot spacecraft efficiently through the solar system. From an engineering perspective, if someone wanted to deploy observation devices across multiple planets, this exact trajectory would be ideal. A craft following this path could drop small monitoring packages at Mars, Venus, and Jupiter without needing to significantly alter its course or speed. And remember, we're not just watching a comet fly by. This thing is threading a cosmic needle, hitting alignments we almost never see. Even more suspicious, the timing of its closest approach to the Sun. Military and strategic angle. Who else is tracking 3I-AT besides astronomers? That's a question worth asking. The U.S. Space Command operates a sophisticated network dedicated to monitoring objects in space. Their Space Situational Awareness program uses radar arrays like the Space Fence system to track even small objects throughout our solar system. Yet, despite 3I Atlas being potentially the largest interstellar object ever detected in our solar system, traveling at unprecedented speeds, we've heard remarkably little from these military and defense organizations. Why the silence? Especially when they have tracking capabilities that could provide valuable scientific data. One possibility is that agencies like AAR, All-Domain Anomaly Resolution Office, and planetary defense groups are using 3I-AT as an opportunity to run real-world drills. This visitor presents a perfect test case for how we might respond to a genuine interstellar threat. It's massive, moving extraordinarily fast, and following an unusual trajectory. From a defense perspective, this is an ideal chance to silently test detection systems, communication protocols, and decision-making frameworks without causing public alarm. NASA insiders weren't the only ones alarmed by what they saw. Defense watchers are paying serious attention, too. The strategic implications of an object that can move through our planetary system with such precision cannot be overlooked. If you're in charge of planetary defense, this is your nightmare training exercise. A fast, massive object from deep space. No way to intercept in time. You'd want to know, is it natural or something you have to worry about? The most concerning part, even if we wanted to intercept 3I to study it up close, we simply can't. Its speed makes it impossible to catch with any current technology. By the time we could launch a mission, this visitor will be long gone. Forensic astronomy, the detective work. The scientific detective work on 3I-ATL began before it was even officially discovered. The brand new Vera C. Rubin Observatory in Chile accidentally captured the comet during equipment testing. When researchers combed through their data, they found a treasure trove: 49 pre-covery images showing 3I-AT before anyone knew it existed. These frames revealed something that immediately caught astronomers' attention. The strange sunward-facing dust tail that defies normal comet physics. Scientists ran detailed computer models of how dust should behave. Under normal circumstances, solar radiation pressure pushes particles away from the sun, forming tails that point away. For 3I-REL to show the opposite pattern means it must have anotropic dust emission. Essentially, it's venting material primarily from its sun-facing side with enough force to temporarily overcome solar pressure. The mystery deepened when spectroscopic analysis on July 3 detected no gas emissions whatsoever. Without gas jets to propel dust, what could explain this unusual behavior? Further analysis of the light curve, how the object's brightness varies over time, suggests 3I-AT rotates approximately every 16 hours. This rotation pattern could provide clues about its internal structure and composition. The astronomical community is mobilizing an unprecedented multi-wavelength campaign to study this visitor. The James Webb Space Telescope will observe an infrared, potentially revealing heat signatures from outgassing and identifying specific chemical compounds. NASA's TESS satellite, normally used for hunting exoplanets, has been repurposed to monitor brightness changes over time. The Swift Observatory will examine ultraviolet and X-ray emissions to detect how the solar wind interacts with the comet. Polarimetric analysis, studying how light waves are oriented after reflecting off the object, could reveal whether its surface is metallic, icy, or dust-covered. And if its ice shows a different chemical fingerprint than Earth's water, that could mean we're holding clues from an ancient alien solar system. Scientists are particularly interested in the deuterium-to-hydrogen ratio, which could confirm whether 3I formed around a completely different kind of star. Exotic science hooks. What makes 3I/ATL truly extraordinary isn't just its behavior, but what it might contain. This interstellar visitor could be a scientific gold mine unlike anything we've studied before. Water ice has already been detected in 31 res coma. But the composition of this water could tell us something profound about our cosmic origins. Scientists are eager to measure its deuterium to hydrogen ratio, essentially the chemical fingerprint of water. If this ratio differs significantly from Earth's oceans, it would confirm that 3A formed in a completely different stellar environment. Even more astounding is 3Th's potential age. Initial studies suggest it originated from the Milky Way's thick disk, a region of ancient stars. This could make the comet an estimated 7 billion years old. Let that sink in. This object may have formed billions of years before our Sun even existed. At that age, it would be the oldest comet ever observed by human astronomers. When spacecraft with magnetometers observe 3I/ATL, they could detect how it interacts with the solar wind. Unusual magnetic signatures might reveal metallic content or composition that differs from typical solar system comets. Inside this cosmic time capsule, there might be trapped interstellar dust grains that formed during the galaxy's early days. Pristine samples of primordial chemistry that have remained untouched for billions of years. If 3I/ATS did form around an older star with different metallicity, the chemical compounds it carries could provide unprecedented insights into how planets formed in the early Milky Way. Think of it like a fossil, but not of bones, of chemistry. If we can measure the water inside, we might find it's older than Earth itself. That's like drinking from a well that was dug before our Sun was even born. This is why astronomers are so excited. Regardless of whether this is just a weird comet or something more unusual. Either way, 3/ATL carries secrets from another star system that could transform our understanding of the galaxy's history. The bigger pattern 3I/ATL isn't our first encounter with mysterious interstellar visitors, and the pattern of unexplained anomalies is becoming impossible to ignore. In 2017, Oumuamua shocked the scientific community with its cigar-like shape and unexplained acceleration as it left our solar system. After ruling out normal cometary outgassing, scientists still haven't fully explained what propelled this object. Harvard's Loeb famously suggested it might be artificial in origin. While most astronomers disagreed, the unexplained acceleration remains a scientific puzzle that challenged our understanding of interstellar objects. Then came Borisov in 2019. Initially appearing more like a conventional comet, it surprised astronomers by suddenly fragmenting during its perihelion passage. This unexpected breakup provided valuable clues about its internal structure, but raised new questions about how interstellar comets differ from our local varieties. These anomalies echo other space mysteries that force scientific rethinking, like the Pioneer anomaly, where spacecraft experienced unexplained acceleration for decades before scientists determined it was thermal radiation pressure. Each time we encounter something from beyond our solar system, it challenges our assumptions. Muir's acceleration defied standard physics models. Borisov's composition and fragmentation pattern surprised comet experts. Now 3I presents even more anomalies. The backward-pointing tail, the statistically improbable trajectory, and the enormous possible size. The pattern suggests something profound. Our models of what exists in interstellar space might be fundamentally incomplete. We keep encountering objects that don't fit our expectations. If two previous interstellar visitors already forced us to reconsider established theories, what might 3I reveal? Its size, age, and behavior make it potentially the most significant discovery yet. This progression of increasing strange interstellar objects creates a scientific narrative where each new visitor expands the boundaries of what we thought possible. And if this pattern continues, what might the fourth or fifth interstellar object show us? 3I might be just the beginning of a new era in astronomy where interstellar visitors repeatedly challenge our cosmic understanding. What comes next? The most crucial chapter in the 3I/ATL story is yet to unfold. On October 29, 2025, the comet will reach perihelion, its closest approach to the Sun. But here's where the mystery deepens further. At that exact moment, 3/8 will be positioned directly on the far side of the Sun from Earth. We won't even see it at its brightest and most active moment. The Sun will completely block our view of what happens during this critical phase. Earth-based telescopes, Hubble, even the James Webb Space Telescope. None of them will be able to observe 3/2 Atlas during this period because of the solar glare. This timing has raised eyebrows among some astronomers. As Harvard's Dr. Lowe noted, being hidden behind the Sun at perihelion could theoretically be intentional to avoid detailed observations when the object is brightest. In November and December 2025, the comet will re-emerge from behind the Sun, becoming visible again to Earth's observatories. What we see then could be reveille. Will it fragment like interstellar comet Borisov did during its perihelion? A sudden breakup would provide a rare glimpse into its internal composition and structure. Might it experience a massive outburst of activity, suddenly releasing gases that were previously undetected? This would support the natural comet hypothesis. Or will it sail through perihelion with no dramatic changes at all? That stability would suggest a more solid, less volatile composition than typical comets. The James Webb Space Telescope might detect exotic ices or unusual chemical compounds in its coma after perihelion, potentially revealing a composition unlike any comet from our solar system. Scientists are even preparing to use spacecraft at Mars and Jupiter that might have viewing angles to observe 3I when Earth cannot. NASA's Perseverance rover, MAVEN orbiter, and potentially even the Juno spacecraft near Jupiter could capture unique perspectives. So, is 3I just a comet? Probably. But it's the strangest comet we've ever seen. And if we don't watch carefully, we could miss the chance to learn from the oldest wanderer humanity has ever caught in its telescopes. Whatever 3 turns out to be, whether an ancient interstellar comet or something more unexpected, it represents a once-in-a-lifetime opportunity to study a visitor from beyond our solar system. Hit subscribe and turn on notifications to stay updated as this cosmic mystery unfolds. Drop your theories in the comments below. And if you found this fascinating, help spread the word by hitting that like button. The truth about 3/8 is still out there waiting to be discovered. As 3I-AT races through our solar system at 130,000 miles per hour, it carries with it secrets from a time before our Sun existed. A cosmic messenger from the deep past of our galaxy. Whether its strange behaviors have natural explanations or hint at something more extraordinary, this visitor has already accomplished something remarkable. It's united astronomers worldwide in a shared quest for answers. The leaked NASA images that started this investigation revealed an object that defies easy categorization. Its backward-pointing tail, enormous potential size, and statistically improbable path through our planetary system have forced scientists to question what they thought they knew about interstellar objects. In the coming months, as 3 swings around the Sun and continues its journey back to interstellar space, we have one brief window to uncover its truth. After that, it will vanish forever, never to return. This ancient traveler, possibly 7 billion years old, has journeyed across unimaginable distances to reach us. In cosmic terms, it's merely passing through. A fleeting encounter between our young solar system and a relic from another time and place. 3A reminds us that the universe still throws curveballs. Some raise alarms, some spark wonder, but all of them force us to stay curious before it vanishes forever. This ancient messenger from another star system is asking us one question. Are we ready to listen? Whatever secrets it holds, whether about comet physics, the chemistry of distant solar systems, or something more profound, 3I represents our best chance yet to understand what lies between the stars. The story isn't over. It's just beginning. And together we'll discover what this cosmic visitor has come to show.